All right, here goes video 2. This question, and I know you can't quite see, I don't think this is a little bit running into the way here, so I'm going to scooch this over. Perfect. All right, so example 2, I'm giving you 3 terms, consecutive terms in a sequence. That's important to know. That means they come right in a row. And I'm telling you it's a geometric sequence. That means you automatically know that the ratio of terms, consecutive terms, is the same. So if I give you the 3 terms, no matter what they are, when I compare these 2 terms, that being 2k over k minus 1, that ratio of terms has to be the same as when I compare this pair of consecutive terms. So that has to equal 21 minus k. Goodness. Over 2k. So what we have is sort of what we looked at when we were talking about geometric mean, and that is a proportion to ratios that are equal. I cross multiply. So this cross product, when I multiply 2k times 2k, I will get 4k squared. And that has to equal this cross product, which is a little bit more complicated. It's k minus 1 and 21 minus k. So this thing I have to actually FOIL out because I don't know what that equals. So I'm going to leave this 4k squared right here. I'm going to FOIL this out. I'm going to get, first is going to give me 21k. Outside is going to give me minus k squared. Inside is going to give me minus 21. And the last is going to give me plus k. So I'm going to move things around a little bit and simplify this. I've got a k squared here and some k squareds here, so I'm going to add this k squared over. So if I add that k squared over here, I'm going to now have 5k squared. This 21k and this k would make 22k, and I'm going to, again, have an equal sign and a quadratic, so I want everything on one side so I can factor this thing, hopefully. So I'm going to take this k and this 21k, which makes 22k, and I'm going to subtract it from over here. And that means I'm going to have to subtract it from the left side, so minus 22k. And then I'm going to add the 21. It's the constant. If I add 21 over here, it equals 0. Now that I have a quadratic equal to 0, I can try to factor this thing. I do have a lead coefficient, which does cause some issues, but it's prime. So I know that one of these has to be 5k and the other one has to be 1k. And then I have to think about what numbers multiply to equal 21. Well, that's just going to be 7 and 3, or 21 and 1. So I'm going to try 7 and 3. And I'm just going to put 7 and 3 like this. And if it doesn't work, I've got to swap them. It's kind of playing the kind of the guess and check game. And so if I go 3 times 5, that's 15. And this is going to give me 7. And 15 plus 7 can give me 22 if I make them both negative. So I guess luck is a lucky guess. And so I have 2 possible answers. What would make this 0 would be the value if k were equal to 3. And what would make this 0 would be if k were equal to 7/5. And if you don't remember how to do that when you have a coefficient, I'm literally solving both of these little parentheses as their own little equations. If either of these equals 0, the product is 0. So if I add 7 and divide by 5, I would get 7/5. So that is my answer for that one. Now you're going to try one similar. You've got 3 terms. They are consecutive. And I'm telling you it's geometric. That's important to know. So you know the ratios, common ratios have to be equal. If I told you it's arithmetic, you know the common differences would be equal. So you've got to kind of read those closely to tell which sequence I'm giving you now. So pause this video and try this thing out. All right, your answer should have been 2. If you did it algebraically, you might have gotten also an answer of 0. But that wouldn't work because if I put a 0 in for k, I'd have 0, 0, 20, and that is not a geometric sequence. So you do, or you should, I should say, check your answers and make sure they work. All right, example 3. I'm again telling you it's geometric. As we move forward from here, you're really going to want to read that because you're going to have seen arithmetic and geometric. So this is a geometric sequence. I'm telling you the second term, not the first term, and the fifth term, and I want you to find its general term. This is asking you to find this formula. UN is the general term, which means I need the first term and I need the common ratio. And remember, this n minus 1 just stays as n minus 1. This stays as u sub n. I need this value and this value. So I don't have it. If I knew the ratio, I could go backwards 1 to find the first term, but I don't. So I am going to use this formula and I'm going to plug this into it. So the fifth term right here is 162. The term itself is 162. I don't know u1. I don't know r, but if u is 5, if n is 5, then this would be 4. So see how I've used what I gave you as the fifth term, and I'm plugging it in, kind of working backwards. Now, I chose the later term first because the common ratio is always the later term divided by the earlier term. So now I'm going to do the same thing I did using this general formula, but I'm going to do it with the second term. So the second term itself is -6, and that would be whatever the first term is, which I don't know, times the common ratio, which I don't know, times n minus 1. But if n is 2, this is the second term. If n is 2, this would just be a 1. I'm going to write it. We usually don't write that exponent up there, but I'm going to write it. Now, in arithmetic sequences, when we were solving for, when I gave you pieces somewhere down the middle of the sequence, you had to use a system of equations, and you could solve it by adding or subtracting those equations together, because there's a common difference, and the opposite of that is adding or subtracting. So this is geometric, so I can't add and subtract these and make anything go away, but what I can do, because it's geometric and the key is a common multiplier, is if the two red sides are truly equal, I can divide 162 by -6, and I can divide u1r4 by u1r1. So these two things are equal, so I'm dividing the blue by the exact same amount, and this I can do. 162 divided by -6 equals -27, and what happens is u1 divided by u1 cancels, and that's how I get to eliminate one of my variables. And r4 divided by r1 is r3, because I can subtract these exponents. And now I can take a cube root, and luckily for me, I know what the cube root of -27 is. If this r cubed is -27, then r has to be -3. And if you don't know your cube roots, your calculator will do a cube root for you. Now that I know my common ratio, I can go back to either of these, the blue or the red, plug in one of my variables and find my missing one. So I'm going to go red simply because I have a smaller exponent here, but it wouldn't matter. -6 is whatever the first term is times my common ratio of -3. If I divide both sides by -3, boom, that's a 3 people. This means my first term I now know is 2. That's all the information I need to be able to write this. So now I know my term is un is first term, which is 2, times the common ratio, which is -3, to the n minus 1. And if I put a 2 up here to check and make sure this is right, then this would be 2 minus 1, which is 1, -3 to the first, times 2 is -6. That's correct, and I'm good to go. All right, you're going to try this, same idea. If you need to go back in the video and pause and see what I did, go for it, do it. That's the beauty of the video. But pause the video, try this one, and see if you can find the general term. All right, video unpaused. That should have been your answer. This should have been U1. This should have been your common ratio. And again, as always, if you have any questions on where these answers on the U-tries are coming from when there's not a bunch of work up here, email. We'll get you the work and show you how it happens. All right, very quickly. Last example, I want to find the first term in the sequence that would exceed 1400. So I'm trying to figure out when along this path, how far along would it be to get to 1400? So again, I'm going to start with my generic here. Boom, U1, R, n minus 1. And what I'm trying to find is what term here would get me to 1400. So I'm going to put this as 1400. Now, if you're official, you might put like a greater than or a less than symbol. But what I'm going to do is I'm going to put an equal to. I'm just going to pretend like it's an equation. Now, look, I know the first term. I told you it started with 6. What's the common ratio? Good question. I have to divide these two things to find the common ratio. So just like the very beginning of these notes, the 6 rad 2 over 6, the 6's cancel. There's my common ratio. It's rad 2. It's not the best ratio that I could ask for, but it's what it is. Now I'm going to solve this for n minus 1. So this is the only thing being raised to the n minus 1, so I'm going to divide by 6. There we go. 1400 divided by 6. I don't think 6 goes into 1400, but 2 definitely goes into both of those. So 2 goes into 1400 700 times over 3. I don't want a decimal here because it's going to get messy because of this square root of 2 business. Now, what the heck do you do now? Well, how do you solve an exponential function? Well, you have a couple of options. You could, I'm going to write them over here, you could graphing calculator. You could graph this equation and this as your second equation and look for that point of intersection. You could graph and find the point of intersection. That would work. You could also plug this function into your calculator and look at a table. Your calculator does tables. I'll show you that in a minute if I don't run out of time up here. And you could look at a table and see when was the first time that your function ran into this. It's not going to equal 700 over 3. It's just the first time it would be exceed 700 over 3. And the other option would be to solve algebraically an exponential, which would be using logs. So if you don't remember logs, you're going to need to eventually because it's a big part of this IB curriculum. So this is the base. So if I want to convert this to a log equation, I got to write log base rad 2. Remember, the base of my exponential is the base of my log, but these two things are backwards now. My input on my log becomes 700 over 3, and that would equal the exponent, which is n minus 1. This I would have to do in a calculator. So if I open my calculator, I can come over here and go second. Oops, I don't need to go second. I can go math. And actually, it's been a summertime, so I might have to go second. All right, no seconds. You just hit that math button right there, and it's just way down at the bottom. I've got this log base thing I can do. So if I choose log base, I can choose it to be square root of 2. So yay, I've got a whole bunch of functions to do here. Square root of 2, and inside of it, inside the log, if I remember correctly, was 700 divided by 3. I don't want to put decimals in there because it's going to round my answer. And that equals 15.732. So this whole mess over here was 15.732 equals n minus 1. If I add 1 to both sides, I would get n equals 16.732. So I want to be the first time I exceed that. And so this would be when it happened. So if I want to get bigger than that, I got to bump it up 1. So my actual answer, very importantly, I have to exceed that. So this is no good. I have to go up to the next greatest integer. So my answer actually would be the 17th term. That's the first time I would exceed 14. If I wanted to hit that 1400 exactly, it would be at 16.732. But remember, these are first term, second term, third term. So the integer values for the terms. So I have to bump it up to the next greatest integer, which is the 17th term. Guess what? You get to try one. You want to exceed 10 grand, 10,000. And again, you can go back to the video, pause it, check it out, look at your notes, see what happened. Give this a go. Pause the video, try this, and then check your answer. All right, video should be unpaused. Should have gotten the answer of being the 9th term. If you did it the way I showed you, you would have gotten 8.75, so you have to bump that up to 9. But again, don't forget you could graph, I wanted to show you where table was. If you put something in your y1 over here, you can go to second table and you can see where the values are in the table. I'm running out of time.